This is JS Signals. We're going to be talking about JavaScript signals, what they are, why you care, and maybe we'll even do some live coding if there's time, depending on how fast. Now, I'm going to be upfront with you. This is a new talk for me. I've never done it before. I was kind of trying to practice it to see how long it would take. I don't know how long it's going to take. So we're going to figure that out together. Luckily, there's a little timer here that's going to like give me an estimate. Ooh. If you keep hearing these like thunks and rips and bumps, let me know. I'll move my lapel there. Okay. Yeah, so my name is Adam L. Barrett. Sometimes I go by Big AB, and I have a full-time job going into other companies and helping them write better JavaScript. That's kind of what I do. It's what I've been doing for the last 12 years, and I've been programming for several years before that. This QR code apparently doesn't work, but there'll be one at the end too that also doesn't work, so yeah. Feel free to give feedback. And I have to be careful of my placement when I'm looking, apparently. So who here is already familiar with JavaScript signals? Just like raise your hand. 1, 2, 2, 2, 2, 2, 2. Less than I would have thought. Indirectly. I'm not saying you got to be intimately familiar with them. I'm not saying the biblical sense. I just mean like, you've heard of them. Yeah, he's heard of them. And everybody else here, you're just like, I don't know, JavaScript, cool. Let's give it a go. Cool. That's exciting. What are JS signals? Does anybody who is familiar or anybody else want to try and take a stab at it? You do. Nice. You want to take a stab at what are JavaScript signals?
Indirectly in Angular.
Yes? All right. They are. That's true. So he said they're in Angular, and so he knows them indirectly through that. So I'll give you my definition of what these are. They're a not-so-new, poorly named reactive state primitive. And I kind of feel like, has anybody ever asked like a functional programmer like what a monad is? You kind of get this answer that's like, oh, it's just a monoid in the category of endofunctors. I feel my answer is kind of the same. Like, what the heck does this mean? A not-so-new, poorly named reactive state primitive. It's not very helpful, is it? But, whoa, there that was. But, every major JavaScript framework right now has adopted reactive signals for their has adopted signals for their reactive primitive. But not React. Oh, he got me. That's true. React actually doesn't. React is all based on diffing. It's basically, the whole thing is based on, hey, is this different than it was before? Kind of goes through a big diffing model. So React, right now, signals doesn't really fit with React. You can use signals with React, and we'll even show you. And some people do. You know, Preact has signals, so it's very, very much the same as, but it's not really their reactive model. Their reactive model is based on diffing. But yeah, Angular, signals. Vue has refs, which are signals. There's even like a list somewhere in my talk here about all that. Also, there is a stage 1 JavaScript proposal to the TC39 ECMAScript committee, whatever you want to call it. I guess committee's already in TC. That's technical committee 39. Anyway, to add signals to the language. Why? What is going on with these signals? About a year ago, all these talks were about signals. It's all I could hear about. So what makes signals so special? If all the frameworks have it, and you're probably hearing about it, and I'm talking about it, why are they so good? And the answer comes down to two things: developer experience and performance. And usually, this is a trade-off. Usually, to get better performance, you gotta have less DevX, less developer experience. Like not as good, a little bit clunky to get the better performance. And usually the easy stuff is like, but you sacrifice a little performance. But in this case, signals appears to be better for performance and better developer experience. And so I think that's why it's so like, oh, hey, really, people are really rallying around this. This is excitement in this area. Because it's like, hey, this should be the obvious next step then. If something's just better in both ways, if there's not a trade-off, it should be the adopted thing. So I guess it's time we actually try to answer this question. What are JavaScript signals? So I said it's a not-so-new, poorly named reactive state primitive. Let's break that down a bit. We'll start with this. Reactive state primitive. What do we mean by reactive? So the idea of reactive is simple, but it kind of gets bogged down in people's terminology or their familiarity with some specific implementation. And honestly, people's just knowledge and terminology kind of gets mixed up over time. What we're not talking about in particular, though, is we're not talking about systems that are responsive, resilient, elastic, message-driven. That's if you go to like reactive manifesto.org, that's nothing to do with this. We're not really talking about programs with asynchronous data streams. You're going to find that a lot, especially because of functional reactive programming. And we're not really talking about an event-based model. This is like the Wikipedia somewhere. An event-based model where data is pushed to the consumer as it becomes available, except that we kind of are, so that one's not bad, but it's not specifically that. So when I say reactive, and what I mean by reactive in this particular talk, is we have a value. When that value changes, anything using that value also changes automatically. And that's like it. It's like a spreadsheet, like with a formula. You know, you change this, the other ones just change. That's all I'm going to mean by reactive. Now, what you do with that is kind of like where the devil is in the details. So reactive languages, things that are kind of more built, sort of have their own syntax and concepts for dealing with this kind of thing. Languages like JavaScript and Python kind of have to make up their own primitives to deal with these systems that are reactive. And that's where it kind of gets messy. But today we're really only talking about JavaScript. So have you ever heard like this thing, I think I've even said it in a podcast once, well, React isn't reactive. It is. Like, it doesn't use like RxJS streams or whatever. It doesn't, whatever. But the idea is you set the state, things change automatically, and you don't have to worry about that. You just go, oh, okay, given a certain state, I'm going to write stuff. So yeah, this is reactivity in that sense. So now that you're really bored, let's take an exploration of reactivity in JavaScript. We'll just quickly sort of step through the evolution of reactivity. So given this code, I don't know if you can see that, it's pretty small, but can't really bump that up anymore. Hopefully that's not too bad. It sort of starts with the basic observer pattern. So in this example here, we've got some browser code. We're going to grab some button and an output. We set these variables count and double. We add to the button an event listener that's going to increase count. And then we have some code that's going to like update the UI, and we call that code immediately just to kick it off at least once. And if I were to run this code, do you guys know what would happen? It would not do anything. That's right. I don't know if you see that little cursor trying to click that button. Might not even be running. Oh well, it doesn't do anything. Because this is not reactive. I mean, you'd have to add this little code like, oh, I have to actually set double again to the same value it was, and I have to call update UI again to make this work. And then it would work, which if this video plays, no. Whatever. You can kind of guess. Maybe I can make it play by touching this. Play video. No. Fascinating. Good to know for the future. Plays on my screen. So that's not reactive. So let's talk about observables for a second. So observables is just a loaded word now. It's really hard to talk about because it means so many different things. There's RxJS, which a lot of people will talk about. That's like, oh, that's classic observable. They even like sort of put in a stage 1 proposal for adding observables to JavaScript. When that didn't really move anywhere, they actually have this other proposal that's in to adding it to the DOM APIs, which is basically adding to like event listener. It's gonna, oh, this, we could get observables in the browser and in Node and stuff. And then of course there's also just like observable in the sense of the observer pattern where there's something that you observe. And so it's hard to talk about. But when I'm talking about observables, all I mean is this thing that you have that allows better composition of events than event target does. So an event target, like anything with like add listener and remove listener, that gives you a certain amount of like, oh, I can respond to events. That's some observability. But when you have an observable, you sort of get these better units of control where you can sort of make functions that sort of take these observables, and it doesn't matter where the source was, I'm now going to make a new value out of this. So you can be like, oh, this is clicks. I take clicks and I add my incrementer. Oh, maybe it's not clicks. Maybe it's every time the mouse moves, I do my incrementer, whatever, blah. Just makes composition of event handling better. So this is the worst and simplest example of observables I could think of. I made it very quickly. I also made some, don't worry about reading this, by the way, but I also made some functions that take observables and make new observables, just to be as generic as possible with like what an observable is. But when you're using these lame observables, they kind of do exactly the same thing. You have your button and your output, your elements from the DOM. You observe the button for clicks, which now makes an observable of clicks. You would then make an observable of count by scanning through clicks and incrementing by 1 every time. You could then, you could then make a double, which is a sort of a derived or computed observable where you just take, you map count, and you say, hey, I'm just gonna double whatever the count value is. And then you can combine those two observables into one, subscribe to that new observable, and say, oh, hey, inner output. Pretty much exactly the same as the event target thing, but done with observables. Observables allow for this sort of nice composition. In this super simple example, not much of a difference. Videos. This is kind of a hilariously bad RxJS example I thought I'd throw in here. Don't do this. There's way easier ways to do this with RxJS, but I just wanted it to look like the last example. So this would be like RxJS, same thing. You just like, oh, I take the events, I make a clicks, I make a count and a double observables, then I combine those together, and I make the output change, and it does the exact same thing. So our next example is going to use what I'm going to call a store. And honestly, a lot of JS libraries and frameworks call this a store. It almost always is, or at least very close. So Redux, for example, was a store. It's a weird store because it's like a store with one node in it, and it has an incredibly crazy reducer inside of it to figure out what to do. But it's a store still. It still stands up to what I'm going to call a store. Zoostand has a store. Svelte 4 specifically had stores. But so how I'm going to define a store here is, we're going to say like, okay, a store is a thing that has a getter, it's going to give you some state. It has a setter, which lets you update that state and updates any listeners. And then you can subscribe to that store. And when you do, you can sort of return an unsubscribe, and that'll give you the ability to like, oh, listen to this thing, you'll get the values. Stores specifically are always synchronous. They're stateful, meaning like you can't wait for a value. You have a store immediately. As soon as you initialize something, you have a value, and then as you update things, you'll always have a value. So even if you were to do async things, what you'd basically do is you'd be like, I'm going to set this to pending, and then when it comes back asynchronously, I set it to not pending, completed, whatever, and the value. Always stateful, synchronous access, and a subscribe function that returns an unsubscribed. That'll actually cover a ton of different things, which I'm just calling store. And these, I actually thought, oh yeah, should have skipped through those two. I actually thought store was going to be the reactive primitive that got popular. And because it was in so many different things and people were kind of discovering it, and then Signals kind of took the thunder away from that. So here's the same example with a store. You can basically get the elements. You create a store with a count state in it, which is 1. You create a derived store, or a computed sometimes, you could call that, which is just a doubling of that count. Then you add an event handler that sets that count to increment 1 by 1. And then you subscribe to the combination of the two and have your output again. And you get the same thing as all the other ones do, which you don't get to see the video. You could say the video is not reactive. Look at this guy. Everybody give him a hand. Give him a small hand, not too much. There you go. Good. So then we get to what a signal implementation would look like. So signals are kind of the next step, I would say, from stores. Kind of excited. So in this case, we'll get more into this, but a signal sort of has this idea that it can create a signal, compute it, and an effect, which we can sort of get into. So in this case, the signal implementation would be, again, we get the elements, we make a signal with count, we make a derived or computed signal with just by taking count and doubling it. Now here we got dot value to give us the value, and that's actually important, but we'll get more into that later. Then you add your event listener, you increase the count, which will automatically increase the double, And there you go. You can subscribe to it sort of with an effect. And the effect here is, hey, we're going to update the DOM every time. And this would do the exact same thing. The effect is kind of like a watcher. Kind of. But we'll get into that more. They actually I'll darn you with your great question. Anyway, so yeah, what do we mean by reactive? All I'm trying to say is these same idea is in all of these. There's just the state that when it changes, everything else updates automatically, the computed thing updates automatically, the effect happens automatically. And so along with that is the idea of at least these two main things, which is deriving values and something can observe it and do something. So the effect in that case, which could be a side effect, you could call it sometimes. But something happens when these values change. So then the other side of reactive state primitive, just to quickly go through it, state, just mean like it's stateful, it's like a data structure. It allows us to use these behaviors. It always has a value. It's synchronous access to that value. And yeah, that's all. By primitive, I guess it just means the simplest and most basic building block of data, I guess. Maybe like somebody, I took something from Wikipedia, a fundamental data type built into a language considered the most basic building block for constructing more complex data structures. Sounds about right. So like what you want as a developer is probably not the signal itself. You probably want a system that's going to be implemented with signals. That'll be a little nicer to use, but because they're kind of popular, we're figuring it out now, you sort of see it's kind of crossing over into both. But you probably shouldn't be the consumers of these actual signals. You should probably have some sort of system built around them. But the signals are primitive. All right. Now the next part of this, not so new. Everyone might already know this, but signals got really popular because of Ryan Carniato. His Solid.js framework in particular. He started doing all these podcasts. He has this sort of regular charisma that I kind of find funny. He sort of meanders when he talks, but he sounds really smart. So you think, wow, this has a lot of like, this guy must really know what he's talking about, because he kind of has this stream of thought as he talks, but he's got charisma. So a lot of people are like, wow, signals must be amazing. Because honestly, when he talks, he sort of goes in and out of like what signals specifically offer and what sort of reactivity in general offers. And so you think you're getting a lot of great stuff from signals. But yeah, anyway, signals got really popular mostly because of this guy. But he'll even say that he didn't make it. Signals were back in this framework called Knockout 2012. And I would even say it's not even there that it started. It's like all over the place for one. But I worked on this framework in 2013 called CanJS, which came out in 2012. And it was created off of a different framework called JavaScript MVC, which came out in 2008, I think. So there's a lot of history. The thing that I worked on in CanJS, it had this thing called computes. And when I saw like a talk about signals, I went, oh, that's just computes. And then my friend Matthew, who also worked on CanJS, we were having a discussion on Twitter or something, he's like, that's just computes. And I was like, I know, isn't that crazy? CanJS, weird library, way ahead of its time, actually, I think. Had a lot of really cool stuff, but just ahead of its time. People weren't ready for that jelly. Yeah, well, I forgot the JavaScript MP3. Yeah, here's just a not, I pulled this off of some blog. This is not a comprehensive list either. This is just like, hey, here's a bunch of things that have pretty much what a signal is. A bunch of frameworks across the years.
Do you have signals right from the get-go?
I think their ref is more like a signal based. I don't know what the previous thing to refs was.
I'm not sure, but I did a deep dive into Vue's history, and I think it mentioned somewhere that Vue has been using signals from.
Okay, so if you can't hear it, person online, he was just telling us that actually Vue has probably had signals since the beginning, not even just refs, whatever the reactivity system was before that. I don't do Vue, so I don't know, but was been signals the whole time, since Vue 2, apparently. At least. So, cool. So what are JS signals, honestly, finally, somebody tell us. Okay, so they're this reactive primitive that can be used like this. You can create a signal. Whoops. Yeah, you can create a signal. So you get these three ideas: signal, computed, and effect. You can create a signal. You can create a computed signal or a derived, sometimes it's called. This is a read-only calculation that is like, hey, from some other signals, I get this, and now I have a new value based on that. And you can be notified that a signal's value has changed by passing an effect, passing a function that will use some signals inside of it, which will then automatically, well, let's get into that later. But it'll tell you when that happens so you can do this. And that's kind of like how you would use a signal. Now, this is a very not complicated example. You can find a lot more online if you're interested, because Angular and went really hard into signals recently, and solid and preactive signals, a lot of cool things you can really check out. So those are the three things that sort of the properties of a signal: the state, they have the derived, they have an effect. Some other properties that are important, though, are they're an acyclic graph. So generally, you're going to have your state in like a graph, and it's like an acyclic directed graph, or what is that? Directed acyclic graph? DAG? DAG. DAG. I love DAGs. Big DAGs. Never mind. That's a weird reference. They're push then pull, which we can get into a while, and they have this auto tracking property that kind of makes them interesting. Sort of adds to the whatever. So I would say that signals are actually an incremental improvement. They're not like, they didn't make something crazy. This isn't revolutionizing JavaScript like you'll see some influencers sort of say on their YouTube channels, like, oh, everything's going to change. It's not going to change. It's a slight improvement over others, but it has that thing where it's got both the developer experience is a little bit better and the performance is good and better. Okay, we're on to something. So just to recap that a little bit, we went sort of like event target, which is like, anything with add listener, remove listener. Then we can have observables for better composition. Stores, which are more stateful, as observables are really more about handling events. You can add a cache, which then makes them stateful, but that's not really what they're for. Stores, on the other hand, are specifically about state and updating state. And then now we have signals, which are basically a better version of stores, and we'll explain why. So how are they better than stores? So if we look at the properties across this, stores can have all this. Stores have state, they have derived, they have effect. So it's none of these. So then we get into this. Well, stores actually can be a directed acyclical graph too, so it's not that one. So we got these things. The properties are push and pull and auto tracking that make it better than stores. So for developer experience, I would say auto tracking is a huge part of that. So how this works is it's the read that's important. It's accessing the value that it needs to be done that's like an important part of how signals work. So you can sort of see here, there's a bunch of different ways of implementing this. So there's the dot value on line 7, if you can see that. That's like a pretty common way because it's got a getter in there. And so it gets to run a function when that value is accessed. And so by doing that, hey, then we can make all the signal stuff happen. We can track its dependencies that way. And that's what kind of makes this better than stores. Because stores, you would have to handle the subscription, whereas in signals, it'll handle it for you. Now there's a bunch of different ways that you can do that. You can make your signal like, oh, it's just a function that you call to get the value out of it. There's another one that's like you get a dot get. This is actually in the spec that we'll talk about, the TC39 spec. It'll have dot get, but it even says in the spec, like, we don't expect people to use this. We expect frameworks to build around this that's better than calling dot get, because as JavaScript developers, we're very picky. He finds that it's not a great idea.
I mean, like, if you're expecting frameworks to handle the dev experience, well, then you're just forcing these frameworks to add a layer of abstraction.
I just want to repeat, he said if you're forcing the devs to write a better experience, then you're kind of like forcing, sorry, what was the last part you said about? You've got this forced abstraction that's going to have to be written on top of it. True? Let's talk about that later. Like you and me. Yeah, what was I talking about now? Oh yeah. So, this is a Svelte example. I don't know how I got on this page, but this is just how Svelte. So Svelte, they just have this new thing called runes, and they even like make this a little bit tighter even because they can use the compiler to abstract away some of that weirdness with the dot value or the calling it like a function. So in Svelte, you create a state rune with this, you create state with a state rune, so count is just a count. Double, you just like say double is count times 2. You get to sort of use them as if the values, because the compiler will add that little dot value or that little dot get that you need to make this work. So it looks a little cleaner in Svelte because of the compiler. So that's maybe one way that this can be smoothed over. Oh, but you can sort of see, I was going to say, you can sort of see it follows the exact same thing. You make a count, you make a double, you update count when it increments, and it works exactly the same way as all the other examples. So the performance comes from both the fact that it auto-tracks its own dependencies every time you read, but also because of the push then pull. So let's diagram this example to sort of see how the push then pull works and how the auto-tracking works, and then we can sort of get a good idea of this. So as always, we start by creating one. Here we go, boom. We make a count signal with 1. It starts out dirty. That's just like how they all start. It's like, hey, I'm dirty to start. Just as the way it's going to work. Then you make a computed, you use the computed to make a double signal. So all computed is you take count, you call dot value, that read's important because it's like, oh, I'm going to set up my dependency as double, and we'll see that in the thing here. So double gets created. And then you make an effect that says, oh, hey, I want to do something, and inside here I'm going to use some of these. And that'll make an effect. They're all dirty, they all exist, and this is it. There's nothing because nothing has actually happened yet. These have just been created. Now effects can execute immediately, or maybe not immediately. They can execute when they're created. That's a choice. For the simple example, we're just going to assume that when an effect is created, it's going to immediately execute itself. But the spec doesn't define this behavior, but in the simplest cases, let's just say they do. So that will cause that read on count, because it was like reading dot value on count. And then what that does is during the read, it sort of sets up the effect as a sink for itself. So the effect depends on a value from count, which they call a sink. And then with that info, it says, okay, we'll also set a source for effect. Sorry, did I say that the wrong way? So count has a sink on it, which is effect, which lets it know that effect depends on it. A source for effect, meaning like a source of a value, is set there on effect that says, oh, I depend on count, so that it's a two-way relationship. It knows, both sides know about each other. Then count determines that it's got a value, marks itself as clean, and calls it a day. The effect then continues to read, and it reads double. So that sets up their sync source relationships. Then double is derived from count, so it makes a read on count. Count's already like clean, so it just gives it back its value. It's like, yeah, sets up that two-way relationship. Then it gives back its value. Double is able to continue. Double calculates itself to 2. Then it goes back to the effect. The effect then is able to finish and marks itself as clean. And that is the state of the tree now. So then the click handler happens, which increments count. Count, the new value is the same as the old values. If the new value is the same as the old value, nothing happens. Otherwise, count goes through all its sinks that it has and marks them as dirty. So in this case, it marks double as dirty because that's a sink. Also marks effect as dirty. Technically, that's it. Effect, it just says effect would actually get set dirty twice because double would also set its things to dirty, but it doesn't really matter. It's dirty. Kind of got myself confused there for a second. Yeah, effect is set to dirty twice. And we technically, this is it. This is all that happens right now. We could set count again and again and again right now, and nothing really changes because nothing recalculates yet. Because sometime later, if this effect is currently being watched, and if it's dirty, then the effect will run. Now, sometime later is kind of funny because it's not described in the spec. And it sort of depends on the framework that's using it, what you think would be appropriate. Maybe sometime later is like, oh, I'm going to just set this up in the, whatever what's the queue called? When you hit, like a promise. The microtask queue, sorry. I might just like add this to the microtask queue. Boom, then it'll happen as soon as like the stack's done. Or it might be like, oh, we're going to use request animation frame for this. So all our effects are only going to run later when the next animation frame is running. It doesn't matter. It depends on the framework. They're going to have whatever they need to figure it out. So the spec doesn't decide in it. But for the simplest example, we'll say, yeah, it just runs on the microtask. So that's the sometime later part. That's kind of important to the performance. So then it gets weird. So then the effect runs. Or interesting might be the way. The first thing it does is it removes itself from its source sinks and then removes all its sources. So removes itself from its source sinks and then removes all its sources. Then it runs its effect again, which in turn calls read, which sets up the source and sink again. Count marks itself as clean. It then reads double. Double sets up its sink and source. Now, because double is dirty, computed signal, it starts the same way as affected by removing its sources and sinks, and then executes the read, which again sets back up the sources and sinks, and then it returns its value. Count returns its value, which is 2, which allows double to calculate its value, and it marks itself as clean, but then it marks all of its sinks as dirty. That's sort of the weird one. A computed value will mark all its sinks as dirty. Now, normally, these will already all be dirty. Like in this case, effects are already dirty. But there's an edge case I'm not talking about because I'm simplifying things. So actually in the spec, there's more states than just dirty. There's dirty, there's checked, there's pending. There's a bunch of different states that I'm kind of just simplifying down to like, dirty, just for this example. But if you want to get into it, it's in the spec. It's very clearly defined. So, but I find this is easier to understand. And it all essentially does the same thing. So then the effect completes, marks itself as clean, and once again, this is the new state of the tree until something else changes it. So the key takeaways here is the read sets up the signal tree's sink and source relationships. There's 2 stages. There's the like notify stage, which is like, hey, a value changed, but then sometime later, the things will start to read again. And so that's sort of the laziness of it. It's like everything is read lazily, and it might not have been changed. It'll only have to do that if something it depends on has changed up the tree somewhere. So between those 2 things, the performance is awesome. There's also the diamond problem. So when you have a regular store, for example, this is again why it's better than stores, or an observable or whatever, you have this diamond problem, which is basically I have one value, then I have another observable that is times 2 that value, one that's times -2 that value, and then I have one that combines them both to give, this new value, which should always be 0 by this. But the diamond problem says this, okay, well, what if I updated value to 2, then synchronously, that would update my next thing because it's push, so this is pushing it out. I'm pushing this value, so that one updates to 4, which in turn synchronously updates its dependency to 2, which then logs 2 because that's the effect that this is. And it's like, oh, wait, this should always log 0. And then it would go with 2 to the other one, bump that up to -4, bump that up to 0, and then it would log 0 correctly again. And that's the problem. So there's this idea of like state tearing, extra things that shouldn't need to happen. And it's because stores and observables are push. So the push-pull allows everything to be set and then only recalculated lazily when it needs to. So you could set it like multiple times, and as it goes up, you're always going to have that correct state value. So a not so new, poorly named reactive state primitive. So I missed one, right? Anyone know why they are poorly named? Yeah, it's hit me.
I thought it'd be like queued signals and slots. I thought it'd be like there would have to be a slot, 120 signals, something like that. I don't know.
Something about signals and slots, that there would be some sort of parity there. It's not why I think, and again, this is poorly named in my humble opinion. Not so humble, I realize. But I think they're poorly named because we already have signals in JavaScript. Like we may not have them in the language, but we have we have a signal, which is a thing in every browser, in Node, in Dino, in all the buttons, whatever. We have it. It's called an abort signal. It follows what generally every other language means when it says a signal too. It's like an observable essentially that says, hey, I'll let you know when something happens. Give me a call back, I'll let you know when something happens, usually just once even. And we have one. It's the abort signal. So if you assume that an abort signal, which comes from an abort controller, by the way, is a signal, you'd be wrong. It's actually a different thing. So that's why I find it's poorly named. Ryan Carniato has actually already apologized for for the name signal. He said in some talk, he's like, yeah, sorry about the name. He just didn't want to call it observables. And there was this other library, SJS, that like had signal, and he's like, yeah, that'll work. So realize it's a problem, but oh well, it's too late now. The horses are out of the gate. No way we're getting them back. So generally, I think that signals are actually pretty cool. They're not going to change everything, but there is a benefit for sure to both performance and DevX. So that's my general opinion on it. So quickly, if there's time, which I have 5 minutes, I think, or maybe more, I would just like to do a little quick implementation of signals to show you how easy they are. So this is that same example I've been showing the whole time. Just a button, make a signal, make it computed, and I just want to implement signals to show you how easy kind of conceptually they are. Now these aren't going to have everything. They're not going to have all the properties, and I'm not going to have time to add them all, but whatever. Okay, let's see what we can do in this short amount of time. Can you all see this okay? Let's bump that size up a little bit. Cool. All right, so let's make a signal. So we're going to export a signal, and this will be like a creation thing. So this will be like a signal which is going to take a value, which I'll just call val for now, and it's going to return a signal. So what's a signal going to have on it? A signal, is just going to have a syncs. So it's going to have a set that is syncs, and it's also going to have a value, but we're going to do it with the getter and setter type signals. So in my little example here, we could do whatever we wanted, but I did count.value. We could make it where it's calls, or we could do set and get. If anybody has strong opinions, yell, do the other one, and I'll do the other one. But for right now, we'll just do it like this. So, and then we'll need a set too for value. So if we remember from the diagramming, when you call get, the first thing that it does is it sets up the relationships. So we're going to need this thing, which is the current running event, or the effect, sorry, the current running effect. And we'll start it at null. But we're basically going to say, okay, I'm always going to give you the value. So whatever the value is here, we're going to just return that. I'm going to return val, But before I do that, I'll say, is there a current effect running? And if there is, I'm going to say, okay, my syncs, I want to add that current effect to my syncs. So that's that relationship of like, I know that the current effect, the effect depends on me. So I'm going to hold that relationship. And then I also want to add that reverse relationship is I want to say, hey, the current effect should add me to its sources. Add me, which is this. So we can jump ahead maybe. Let's go down to effect to implement that. So let's export an effect. So an effect takes a function. This is a function that takes a function to create this effect. Woo. Missed an equal sign. And it is not going to return anything, actually, but it's going to set up the effect inside of itself, and the effect is going to do something. So we need something to represent this effect, though. So I'm just going to call this like underscore effect, and it's going to have an object. And this object is going to have sources, which is a new set. We need that for up above. And then I'm also going to give this a run method. It should just be like, hey, run this. And then just because of the way we talked about it earlier, the simplest thing to do is like, these can just synchronously run themselves. This isn't necessarily part of like how you do it, But just for easy, I'm just going to say, hey, the effect that I just created, call the run method on it. So in the run method, when an effect executes, the first thing it does is it removes those relationships. So it would be like, oh, okay, I'm going to, my brain, sorry. Is there a current effect? Actually, I don't even know what to say if, is. I'm going to say, let's stash the current effect, because I want to be the effect when this runs. And I'm going to do this synchronously. So I'm going to say the previous current effect is whatever the current effect is right now. Then I'm going to say set me this effect as the current effect. And then I'll say, okay, now that I'm the current effect, let's run this function that you passed. And that'll that'll do all the reads, which will set up those relationships and stuff. And then after that, I'm just going to set the current effect back to whatever it was before it called me. Because I might be part of like an inner tree somewhere. So I'll just return it back to the previous. Now the only thing I forgot to do here was I forgot to clean up those relationships. So the first thing I got to do then is I got to clean up all those relationships before I run. So I'll say this sources, and for each of these sources, I will say I got my source, and I'll just say source syncs. So these are going to be things with syncs, the signals with syncs. I'm going to say this syncs remove or delete me. So, and then I got to clear out all my sources too. So I'll say this source is clear, if you remember from the graph. Then I run the effect, do this. I'm missing a lot of stuff about error handling and a lot of stuff going on here, but doing good so far. All right, so then when I set a value, I'm going to use this for this back to the signal. When I set the value, I want to set val. I'm just going to use this trick that like some people hate. So this will be a new value. I'm going to use the argument as the variable because it saves me a line. But I could just as easily put this as a, so I'm going to use the argument that you passed to the original signal as the variable that's going to hold on to this. If you don't like that, you can always just make a little closure here and make it like a state value or something. But whatever, this is fine. And then all I have to do is I have to go through all my syncs for each. And I say, hey, you should call those because they are going to be effects. So all my syncs are effects. So I'm going to say, hey, sync, call your run method. Now, one thing about this that's odd is that actually running these may add or remove syncs. So I need to do this thing where I say, hey, I just want whatever the current snapshot of these syncs is right now. So I'm going to do that. All right, we're almost there. So now computed. So if you think about computed in a certain way, a computed is just a signal that has an effect inside of it that says, hey, when this effect runs, update my value. And then it doesn't have a read. It doesn't have a set function, essentially, right? It's read only. So if we do that, we'll just say like, okay, export const computed, or what did I call it? Yeah, computed. And that computed takes a function because it's like, hey, how are you going to compute this? And I'm going to start with just adding a signal here. And then the initial value here doesn't matter because I'm going to synchronously just update this, right away. So I'm not even going to add a initial value. And then I'm just going to add an effect where the effect is call that function and set my value to that function, whatever the result of that function is. And then I need to return the signal. So if I hit save, what happens? I've messed up somewhere. Let's see where. This is my one problem with simple browser, by the way, is it doesn't have a console, so I got to use this little guy. All right. Duplicate export of effect. Did I call it effect? Oh, I didn't need to do these exports, right. Except for the bottom one. Whatever, get rid of this line. There we go. Oh, something else wrong. Woo! He got it. Nailed it. Line 25. Sinks is plural. Boom, do, 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 do. And there we go. So that's how simple it is. What do we got here? 42 lines of code with a lot of whatever. Now this is obviously missing a lot of stuff. The big one this is missing right now is it doesn't have the push-pull. That's the major thing. It's like, hey, one of the major things is not in there. It also doesn't, actually prevent reads on a computer. There's a bunch of stuff it doesn't do. It doesn't handle errors and whatever. But this is a good starting point for the idea of like, this is how signals work. Whoops.
I just want to see for computers.
You want to see something for computed, sorry?
Well, just how you did computers.
So computed is just make a signal, make an effect that updates that signal to the function passed value, and then return that signal. And we can find our slides elsewhere too. But let's go back to the slides. So quickly, because I think we're out of time.
Well, you're the last one, so if
Woo! You guys can leave if you want, but I'll just say quickly.
if you want to take some more time.
1 minute, 60 seconds. I will say, what's the current state of the standards? It's still stage 1. It's going to be stage 1 for a long time because they have very lofty goals for moving to stage 2. They want to have their polyfill that they have up there, which you want to check it out, in at least 2 frameworks being used before they say, oh yeah, this is even ready for stage 2. They want everybody to try it. There's a great polyfill because you can sort of have everything. The one thing that, well, maybe not one thing, but one of the things that by adding it to the JavaScript language it'll handle garbage collection better, because right now there's a situation where you can sort of have these dangling things that you gotta have to deal with. If you could have it in there, then you could say, oh hey, garbage collection can just be handled by the browser, and that would make them a lot better memory-wise. That's my whole talk. If you have any, you can check out the slides, it's slides.com/bigab, that and all my other talks you can see. I don't think that QR code works. If you have any questions, feel free to come up and talk to me. And yeah, thank you all for coming to my talk. I hope you enjoyed it.